Trigonometry. This word brings up a collection of topics that is practically essential in the world of science and engineering. Yet there are other applications in everyday life where it can be quite useful. In the first picture, we have a building and its cast shadow. We can calculate the height of the building by placing a thread vertically on the ground and measuring the lengths of both cast shadows and the thread itself, and with the theory of similar triangles. Next, we have a lighthouse and a nearby boat. We can find out how far the lighthouse is from the boat by measuring the angle A and knowing how high is the lamp of the lighthouse from the ground. The last picture shows a calculation in determining the height of the shooter by knowing the angle relative to the ground and the horizontal distance from the calf wound and the point of fire. These pictures show a few applications of trigonometry. After all, trigonometry, or let's call it trig, is made for measurements. It is defined as using the triangle or trigonon for measurements, or metron. So a triangle is almost always going to be involved when trig is brought up in a discussion. This video brings up an introduction of trigonometry in a different way. It is usually brought to us in this order. However, I want to talk about it in this order instead. I'd also like to bring up the term complementary angle here, and it's because not only it has something to do with how I'm going to reveal their definitions and show them in the diagram as I promised, but also with that order, which is actually one of the things that fascinates me about the topic. Consider a right-angled triangle. To start, let's mark the angle theta right here, and then label all sides with initials of their names called the hypotenuse, adjacent, and opposite sides respectively. Keep in mind that theta is always included between the adjacent side and the hypotenuse or longest side, and the opposite is always located on, well, the opposite side of theta. Next, we shall define each trigonometric function in words. I like to define the sine of theta as the ratio of how long its opposite side is and how long its hypotenuse is. The tangent of theta as the ratio of its opposite side and its adjacent side. The secant of theta as the ratio of its hypotenuse and its adjacent side. Remember that these functions are actually ratios between exactly two sides of a triangle in length, and you can treat sine, tangent, and secant as their respective names. Now let's bring up the definition of a complementary angle. It is the additional angle needed to complete an existing one such that they add up to a right angle or 90 degrees or pi over 2 radians. So looking at this right triangle, which we know that the total amount of its angles is always 180 degrees, if one of them is 90 degrees, the other two must add up to 90 degrees. And since we already labeled one of them as theta, the other angle will need to make theta add up to 90 degrees, making it the complementary angle of theta. Now, why are we doing this? Well, if we apply the same concept for complementary theta, we can obtain the sine, tangent, and secant for that angle as well, which brings me to the remaining three functions. The cosine of theta is actually the sine of the complementary angle. In fact, the cosine got its name because it is derived from the abbreviation of complementary sine. Similarly, the cotangent and cosecant functions are the tangent and secant of the complementary angle, with their names as abbreviations from complementary tangent and complementary secant respectively. So now we know the relationship between those three functions and the complementary angle. Let's now define those functions by applying the same concept as for the first three. The cosine of theta would be the ratio of its adjacent side and its hypotenuse, and these two for cotangent of theta and cosecant of theta, each for their own reasons. We can also obtain the relationships between the functions, simply using multiplication of one, the theory of fractional division, and the Biru substitution. started with tangent theta, multiply it with 1 over hypotenuse over 1 over hypotenuse to the equation to get this, and by substitution, it is equal to sine theta over cosine theta. Secant theta can be expressed as 1 divided by adjacent over hypotenuse. Substituting this by cosine theta, we'll have it equal to 1 over cosine theta. Cotangent theta would be 1 over tangent theta, and cosecant theta would be 1 over sine theta. And for which triangles can trig be applied, we can also apply it to other triangles instead of just right triangles, since they can always be broken down into at least 2 of them with a little bit of geometry. Now let's proceed to the unit circle. A unit circle is a circle with the radius of 1 unit. I will call it pretty handy when it comes to help us visualize the functions. So consider one here. Locate the x and y axes through the circle with the point of origin at its center. Next, fit the triangle we had before into the circle such that its hypotenuse fits exactly with the radius. We also need a tangent line, a line intersecting a curve at exactly 1 point. In this case, let the line intersect the circle at this point. Since the hypotenuse is now equal to 1 unit, we can substitute 1 into the functions we had before. Sine theta would be O, which is also equal to this segment here. Tangent theta would still be O over A, and it would be here by manipulating the theory of similar triangles. Secant theta would be 1 over A, located here. Cosine theta would be A, which is this segment here. Cotangent theta would be here, and cosecant theta would be here. We can use this diagram for solving word problems, like for instance, working out the distance between these 2 points or other 2 points by knowing something about theta or vice versa. So to recap, trigonometry is all about measuring triangles, which can be found in science and engineering, navigation, design, geography, computers, video games, and more. The 6 trigonometric functions are ratios between 2 sides of a right triangle, and they can be visualized with the unit circle, which is a circle with 1 unit of radius and a pair of xy axes. Thank you so much for watching. If you like this video, please consider hitting the like button. You can leave other math topics which you would like me to cover in the comment section below, and subscribe to keep notified for more videos. Thank you, and I'll see you in the next one.